But today I have this Cary Monoblock amplifier, and you can see right off the bat that one of the tubes is getting so hot that, well, in this case, it actually vented. From what the customer described, it had gotten so hot within just a few moments of being on that this happened. Now, I find it really interesting that this is the only one affected, and there seems to be no problem with any of the other ones, so have a look at that. And it looks like there's another tube missing. So, let's flip this thing up and see if there's anything. Oh. Oh, this is going to be tricky here. Let's try moving the battery over. There. Genuine bona fide amplifier prop. Oh, look at that. Got a burnt resistor right there. But that one goes down to that tube down there, which is not affected unless he swapped the tubes around or something. Everything else kind of looks okay. I'll get the meter out and make a few checks. Okay, so obviously this burned resistor is supposed to be 10 ohms, is wide open. And oh hey, that one's open too. They're probably just like fusible resistors which have served their function, but I'm surprised this one's open too. It doesn't seem to be burnt. It's burned on the back side. Let's check these up here. Oop, that one's good. 10.2 ohms and 10.2 ohms. Something nuked these, and not quite sure what it is yet. About these ultra precision 1% resistors this thing has peppered throughout it. It's a pretty nice amplifier, actually. Built the old-fashioned with the old-fashioned point-to-point wiring and minimal solid-state components. This resistor right here, 1.22K, 0.1% tolerance. And that one measures 1.22K. Oh, okay. 1K. This one should be 1.22. If I can get on it. Yep. This is 50K. It looks like 4.9 something. So yeah. 163.4K on this one. That is ridiculously tight. 162, yes. See if any of these electrolytics are shorted or anything like that. Let's do a quick check on these. This polypropylene or mylar, whatever this is here. Is this a capacitor or a resistor? 70K, so it's a resistor. Checks good. And that one. Come on. Come on. It's good. 70K. 57.7. Is that? No. 4.5K. For 420 ohms. Well, here's what I found. Those two resistors in there obviously were nuked, and I replaced those with some carbon comp resistors. And according to the schematic, let me get a focus on this. Yeah, all those 10 ohm resistors are actually in the cathode circuit. You've got one per tube. You see the cathodes, and they all combine together and come over here to a 1/2 amp fuse right to ground. And that fuse was blown too. So what I've done, I checked around. I didn't see any obvious shorts to ground. The output transformer wasn't shorted to ground, anything like that. I've had output transformers fail in such a way where it draws way too much current through an output tube. It gets red hot, it red plates, and it will cook the tube short order. But what I've done here, I've replaced those two 10 ohm resistors, replaced the fuse, dropped a couple of tubes in there that are known good tubes, and now I've powered this thing up. And the pair down there, it's been on for a good 5 minutes, and it's, they seem to be drawing a moderate amount of current. And, I don't know if you've ever had to deal with a bad output transformer or a tube that was short-circuited in some way, but they get so hot so quick that you can almost smell them. They smell like a toaster within the first 10 seconds, and usually you turn it off, and the glass is literally so hot it scorches your skin just touching them. And that's not happening here. So I think the original problem had to do with some failed output tubes. I think a tube failed and it just started a chain reaction, because I see nothing wrong with this now that those repairs have been made. So I'm going to let it cook a while, and then we'll test it out, see what happens.